Hi, in this tutorial we are going to learn a bit about the basic random walk process, which is the stochastic process, and we'll also try to replicate the random walk process by writing a Python code, and we'll see by ourselves that how the outcomes from a random walk process look like by taking an example. Okay, so first let's understand what a random walk process is, and then we'll be able to write a proper code. All right. So to understand what a random walk process is, we can take an example. So graphically, it is easy to understand a random walk process. All right. So here is a graph. So it's a XYZ plane. It's a XY plane. The y-axis has the positive y-axis is there. This is the positive, and then there is also the negative y-axis in and we have only the positive x-axis. So what happens here is that we consider the random walk process starting from the origin. Okay, and then we toss the coin, and every time we get, let's say, head, then we move +1, and every time we get tail we move -1. Okay, so the reason why it is called random walk, because somebody is walking from the origin and it's completely random, because when you toss a coin there is 50% chances, right? So the probability that you will get head is 0.5, the probability that you will get tail is also 0.5. So it's completely random that whether it's going to take a positive it is going to walk towards the positive side of the y-axis or the negative side of the y-axis, right? It's completely random, hence it's called a random walk. You cannot know for sure that, okay, after certain step at what position, or what is the distance from the origin the person is uh, just by finding a pattern in it. So there is no pattern as such, because the probability is 50% for both the cases. Okay, so the different types of paths that one could take are given by the different paths I can see in different colors. So this could be one path, this could be one path, this could be one path. So it could be anything as you can imagine. Okay, if you look at the first one, okay, this one, the light blue one. So it takes first step, it comes out to be head, and then it takes a +1, and then it becomes tail, and then it takes a -1. So now the path traveled by this person in the first two steps is actually +1 -1, which is equal to 0, right? It comes here and then comes back. So the path is again 0. That means in the y-axis it hasn't traveled anything, right? So y-axis denotes the path traveled by the person or the particle or whatever. Okay, and then again there is head, so it travel for +1. There is head again, so again +1. So the total distance is 2 now, and then it comes back. So it's 2 minus 1, then the total distance is again 1. And then it keeps coming down, going up, and so on. And the final distance is nothing but only the distance this one. Okay. Similarly, for the green curve, you can see there are different outcomes from the toss, and you can see the final outcome is totally different from the individual outcomes that we have seen, and there seems to be no pattern which can be modeled. And this is an interesting problem. This is interesting in concept, because this concept is found in this type of path is also followed by gas particles, by stock market, mm, uh, by different stock market indexes, by stocks, and also the particles inside the atom. Okay, so So we can actually see for sure that how the outcomes looks like after a certain number of paths, and we can do some sort of a simulation. The simulation exercise will tell us how the final outcome look like, you know, by ensuring that we we use a fair coin and take a decision on that. So what is a fair coin? That means the probability of getting head and tail is exactly same, right? So if it's a fair coin, the probability of getting head is 0.5 and the probability of getting tail is also 0.5. Okay, and then you're for sure that, yeah, we are we are able to find out a completely stochastic process, um, with +1 -1, distance traveled by the particle or the stock every time there is a toss. Okay, so we'll just replicate this. We'll just do exactly the same thing using the Python code. All right, so to get that randomness, right, to toss a coin, we'll import the package random. Okay, uh, now we'll also do a toss. Okay, so if you toss something, so how do we do a toss? We just assign toss as a variable to random dot randint, and then we'll toss, let's say, 30 times. Okay, let's first, okay, all right, not 30 times. Okay, so we'll just toss a coin by taking a random number from 1 to 100, right? So if you get a number greater than 50, let's call it as head, and if you're getting a number less than 50, then we're calling it as tail. Now the 50% chances is there because we are taking numbers from 1 to 50, that the number is going to be less than 50, and 50% chances is there that the number we find from this random package is greater than 50. So it's pretty much like, or it's similar to what we get in a toss of a coin, right? 50% of chances of happening either of these things, either of this outcome. Okay, all right, so we'll also print what we get here. Okay, so we'll print toss. So let's save this code and then run this, and let's see what we get. All right, so every time you compile this code, you will get a number which lies between 1 to 100. Okay, let's compile once again. Let's compile once again. Okay, so this time we got 32. Last time we got 15. Okay, so let's do once again. Okay, 79. So sometime it's like, every time is greater than 50. So we were calling it as, okay, we're getting a head, right? That's exactly as head. So it's going to take a positive one, right? And every time there's the number is the outcome of the random number generated is less than 50, then we're calling it as a tail, and then that's going to or the in the random work we're going to take a negative one, right? And that's what we're going to do later on. Okay, so this is how the random number gets generated. All right, now what we can do is that we'll write a condition. Okay, if so how do I write a condition? If toss is greater than 50, then count, we'll just take a count. Okay, count equal to count plus 1. Okay, so we're simply adding 1 plus 1 to the count every time we get the value of toss greater than 50. Okay, else count equal to count minus 1. That means we're subtracting 1 from the count if it is less than 50. Okay, so the value in toss, or the random value generated, is less than 50. That means we are getting tail in this case. In the earlier one, in this case we are getting head, right? So that's what we are assuming here. Okay, and then let's print what comes out in the uh, count. Okay, and we'll do it, let's say, for 50 times. Okay, so 50 number of times we'll get a random number from 1 to 100, and then we'll check if it is greater than 50, and then we'll increase the count, and if it is not greater than 50, then we'll also we'll decrease the count by -1, and then we'll print it. Okay, that's what we're trying to do. So let's I in the range 1 to 30. Okay, or maybe 0 to 30. All right, and we have to define or declare what is count, right? So let's start with count equal to 0, and then it's going to get incremented with the iterations. Okay, so we want 50 number of times, right? So we're tossing the coin 50 times, right? So we're tossing the coin 50 times here, and every time we get a head, we are adding 1 to count, and every time we are getting tail, we are subtracting 1 from count. Okay, and then we are printing what is the value of count in this case. Okay, so let's save this and let's compile this one. All right. All right. So we are printing all the steps. That when we have 50 number of times where we are you know all right. So what we're getting here is that the value of count in different steps. Okay. In the first step, we're getting the output as -1. So guess what would have happened? So in the first step, the number in the toss is less than 50. Okay, so we've got a tail. That's why the count becomes 0 minus 1, which is -1. That's what we're getting, -1, right? And in the next step, we got a positive, we got a head, because the value of toss is greater than 50. And that's where we got -1 plus 1, which is 0. And that's what we're getting here, right? It's 0. And the next step, we also got positive. So it becomes +1, and then again we got positive, so it becomes +2, again we got positive, +3, again we got positive, a head, right? So it becomes +3, +4, and +3 and +4, and then +5. Okay, so 4 number of times we got heads consecutively, and then we got tail again. That becomes 5 minus 1 equal to 4, right? So you can see what could be. I mean, ideally you will expect that, okay, plus minus, then it will cancel out. You probably get 0 at the end. But you can see at the end, after 15 number of times, you are not getting 0, but you are getting 2. So the distance travel in 50 steps, or by tossing a coin, or by 50 steps, or random walk steps, the final distance travel is 2, right? We expect that to be very closer to 0, but number of times it's not 0. Okay, let's see. Now this time it's closer to 0. Let's see if we do it again, whether it's closer to 0 or is farther away from 0. Now in this case you will see it's farther away from 0. We're getting a number -16. That's far away from the x-axis, right? And that's not very close to 0. Ideally one would expect that plus minus, and then it's going to cancel out and it's going to be 0, but here we can see it's not 0, it's -16. So let's see a couple of more times. -6, minus 4. So you can see, continuously we're getting, the final distance travel in the negative numbers. Okay, let's see if we're getting a positive number. Yes, so we got a positive distance now. Okay, so the final distance travel is 8 in this case. I'm just curious to know, shall we get a 0 also? Let's see. Okay, so this time we got a 0. That means after 50 number of steps, the total distance travel is 0. So you can, what we can do is that we can just take these steps and plot it, and you will find a distance or a a graph or a plot like the one I showed you in the beginning. Okay, all right. Now what we'll do is that let's do this activity. Do it for 100 times, and then um, let's take the average of it. Let's take the average final value of the average final value, and let's see if that comes out to be closer to 0. Okay, why are we doing it? Because when you increase the number, the average should be close to 0. That's what we believe, but let's see if that happens or not. Okay, so we'll just write another for loop. Okay, for let's say j equal to j in range 1 to 100. So what we can do is we define another variable called count sum equal to count sum plus count. So what we'll do is that so the final value of the count, which is nothing but the distance travel in 50 number of steps, will be added to count sum. Okay, so let's do it. Let's do it only for once, and let's see if it is correct. The code is correct. Print count, and we also print count sum. Okay, and then we'll also count sum equal to 0, so we need to assign it. Okay, so let's save this code and let's run this code. Invalid syntax, something is wrong. Okay, colon sign. All right, now you can see the final value is minus 10 for count, and count sum is minus 10. That means count is getting added to count sum. That's what I was trying to check in this case. So let's do another thing. Is it same? Exactly. So the last two numbers should be same, right? Let's do once again. The last two numbers are same. Okay, so that means the code works fine, and then we can do it for 100 times. Okay, so that we can calculate the average, right? So I'm not sure if it's going to run for 100 times or 99 times. Okay, let's take the average of that. So we'll take the average of count sum by 100. That means we're taking the average of the sum. Okay, and we ideally expect it to be close to 0. Okay, because that's what we have learned from the law of large numbers, that if you increase the number of trials, you will be you'll be very close to the expected value, right? So let's see if that is true. Count sum outside this loop, because once okay, so we'll take the count sum outside the block, so that every time the inner loop is finished, we'll just get the value of count, and then it will get added to count sum. Okay, and finally after the 100 times of tossing this coin again and again, 100 times of simulation in the outside block, so we can take the average we can print the average of it. Okay, so remember the so in your block, what we are getting is the final distance travel in 50 different steps. Okay, and in the outer block we are doing it 100 times and taking the average. Now the idea here is that if you do it more number of times, you will get the average value close to zero. Now what is the intention, what is the objective behind it, behind doing this experimentation? In the previously what we've seen is that sometimes the final distance traveled by the uh, particle or the stock is sometimes closer to zero, sometimes is far away from zero. So it's pretty random. So what we're expecting by doing it for 100 times, that the average should be close to zero. Okay, and let's see if that's true, because that's what the last number tells us, right? That if you do the same experimentation over and again and again, you will get closer to the expected value. So let's do this. Okay, so let's save this and then let's run this. So we've got a number minus 0.1.34. That's very close to 0, right? So let's run once again. This time we're getting 0.14, even closer to uh, 0, right? Once more, 0.46, that's also very close to 0. 0.06, that's very close to 0. Minus 1.0, close, very close. 0.02, very close to 0. Minus 1.56. So it proves one thing for us, that if you do the random trial for a very large number of times, you will get a number very close to what you are expecting. So we have done it for 100 times. So can we do it for 1000 times? And let's see if that value gets even uh, more closer of it's even very close to what we are expecting. Let's see. We run this. Okay, it's not. So minus 2.84. Okay, so the variance is more in this case. Minus 1.44. Okay, so you can play around with this. Okay, you can increase the number, the value of n, and see how the expected value is, or the expected distance traveled by the random particle. Okay. So thank you for watching this video, and please subscribe to our channel for new videos on analytics, data science, and quantitative techniques. Thanks for your support, and please subscribe.